Hi everyone, I hope you are doing good. So today we will take a new C++ topic in this advanced C++ series, and the topic is C++ templates. So this is very commonly asked question in the interviews related, from the templates. So I thought let's take it up. So in this video we will cover each and every aspects and scenarios of the C++ templates with the examples. So like we will cover the template introduction, like what is the template, how can we use it, what is the requirement of the template, why came it into the picture, and then we will discuss the all types of the templates like function template, class template, variable templates with the examples. Then we will understand the template parameters like type and non-type parameters and the default arguments in the templates. And then we will discuss the template specialization like full and partial specialization with the either function templates or the class templates. So each and every aspects and scenario we will cover in this video. So I'm expecting that after watching this video till end, whatever the query you are having related to template will be resolved and will be addressed. So basically after this video, if you go and give an interview, then I can assure you that after watching this complete video, you will be able to answer each and every question related to template in the interview. So let's start with the requirements of the templates. Why the template came into picture in the C++. So I have added here two functions, my functions, which is basically printing x and y value to the console. And then one more I have added my functions. Basically I am doing the overloading of the functions, right? For the character type here, x and y, and I am just printing this one. So the functionality is same for both the functions, except the data type here. Except the data type, everything is same for both the functions, right? Now the requirement came is that we have to print the double data type also, right? So for that, what we can do now with this one, so we can add one more function here, right, with the double data type. See here I have added one more function with double x and y. So this will print the double value, and from here I can call, right? I can add one more call here for double, right? So I have added one more function here, my function for double printing the double data, right? So likewise, if now after some time the requirement may come, like we have to print the string data also, right, character data also, some other data types also. So now this is not a good, right? So so this was the limitation before the templates. Then C++ basically gave us a new feature that is called templates, right? And using the template, what we can do now, instead of these three functions, we can add only one generic functions, right, which can take the basically the data type as an argument. So here what we are doing, we are just passing the arguments x and y values only, right, not the data type x and y we are getting from the function, correct? Now it would be better if we get the data type also as an argument, right, with the values. So that would be great, because then what we can do, then instead of then what we can do, then we can write a generic function, one function only, that takes the data type as well as the arguments value, both we can take as an argument. In that case we can write a generic function, right? And that would be great, because now as of now we are adding three functions, but with the templates, right, which allows us to take or which allows us to write a generic code which can take the data type as an argument. So using that, what we can do, we can write a single function, right? So that we will see, right? So I hope the requirement is clear to you. So without template we cannot write a generic code on the basis of the types, right? We must have to write each like separate functions for the each data type, right? To overcome this problem, to this limitations, the templates came into picture. So now coming to the templates, so there are three types of templates: function templates, class templates, and variable templates, right? So now first understand the template syntax, right? So let's take this example here. The syntax is simple. What we have to do, instead of these these three functions, we can write a single function, right? So here I have added only single function, one function for all data types, right? And how we can achieve this one? So we have to use template keyword, then this is less than sign, and this is greater than sign, right? and between this less than and greater than, we have to basically define the parameters. So here what we can give template keyword, right? Then here instead of class you can give type name also, right? So I will use both in upcoming examples. So this is the syntax basically for the template, and this is the entity, right? And this is the template definition. So you must have to remember that the template is applied on the entity definition, right? Template must be applied on some entity definition. Now entity could be either variable, function, or class, right? These three can be the entity for the templates. So or you can say these three entities supports the template in C++, right? So now here I am taking t1 and t2. I am giving this, these are the variable names, and this is the type class, right? It could be type name also, correct? So and here t1, so here what we will do now, t1 I am using instead of the integer or character or double, and t2 is also I am using instead of the integer, character, or double. And this is now complete definition of the templated function, you can say, right? And then the second step is, first is definition of the templated entity, or you can say template with the entity, then instantiation of that entity, right? Instantiation means calling, right? So this function we have defined here, now we have to call this function, then only it is usable. So from here we are calling this function, right? And here instead, see, here in the last example we are directly calling with the arguments only, argument values basically only, not the data type, correct? Here integer x, a character x, right, or double x. So here we are just passing the values. But here the difference is, while instantiating or calling the function, we must have to pass the data types as well, right? Because we have added the template, and the function, the entity is templated entity, which also basically need the type, right? Because we have defined a generic function which can take any type. So here we are passing integer, and here we are passing character. So now no need to write basically two functions here. We have added only one generic function which can take the data type as an argument. Or you can say the templates allow us to write a generic function, generic code, which can operate on the different data types, right? Instead of writing separate functions for each data types, we can define a single function which can be used. So now I hope it is clear to you that what is the requirement. So right, so without template we have to write multiple functions for the same functionality, which for the different data types. But with the template feature, we can write a single function which is different in the data type only. The functionality is same, right? I hope it is clear how it works. So here this is the job of the programmer, right? So we have reduced the basically work load on the programmer. Programmer can write simple single function, but now compiler took the responsibility to write the different functions. So what does it mean? It means like compiler will basically write two functions here, right, in the assembly file. So for each data type, so here I have added one more call here for double. So in this case, the compiler will add 3 copies of the same function here for each and every data type, right? One copy it will create for the integer data type here, another copy it will create for the character data type, and third one it will create for the double data type, right? So earlier we were only doing, right, programmer only doing the 3 copies, but now programmer will add only simple single copy, right, with a generic data type, and then the this job is transferred to the compiler. Now compiler will handle it. It will write 3 copies for each data type, right, while compiling, correct? So let me show you the proof for this one. Now we will see the basically assembly code where the 3 copy will be created. So here what we will do, I have to give the option S for assembly, and see here this this file got created assembly, and here let me show you the main function. So this is the definition of main function, and in main function you can see my function, this one. So these 3 calls from the main functions you can see in the, this is the assembly file .s, and here one call is this one, second call is this one, third call is this one. Now go to the definition of this one. So one definition is this one, right? This is the one definition. Second definition is this one, right, from here. and third definition is this one, right? So three definitions got created for the same generic functions for each and every type. Now let me dump it in a readable way. So here this dump file got created, and here it will be easy like readable format. So here let me search for the my function. See here, these three are the calls, right, from main. One for double, one for character, one for integer. Now go to the definition here. So here see, one definition got created for integer t1 equals to int, t2 equals to int. One definition got created for t1 equals to character, t2 equals to character. See here, and one more definition got created here for t1 equals to double, t2 equals to double, right? So three separate definitions got created in the assembly file. I have shown you, right? And also I have proved by seeing this dump file here. So now it is clear that now the job earlier we were doing only programmer only doing it is adding the separate copies, but now using the templated functions, we have added a generic function using the template, and the job transfer to the compiler. Now compiler will create a separate copy for the generic functions on the basis of the instantiations or on the basis of the data types which we are passing, right, while calling the function, right? So this is the example of the function template, right, because the template we are applying on the function. Likewise, if we apply the template on the class, then that is the class template, and likewise if we apply the template on the variable, then that is called variable template. Now coming to the class templates, function templates we have seen. So class, so earlier we were in the last example in function template we are applying this template on the function entity, but now we will apply the template on the class entity, right? So that is class templates in C++, and it allows us to create the classes that can handle any data type, right? Instead of the defining a class for each data type, like functions for each data type, we were adding separate functions, correct? So here I have added a class which can take two arguments here, two parameters of data type, right, t1 and t2. Instead of int or char, I am just giving t1x or t2x, right? The type of x is t1 and type of y is t2. And one more thing, let me explain you. The template get resolved at the compile time. So at the compile time, the compiler creates the separate copy on the basis of the data type. So that is why this t1 and t2 get resolved at the compile time only, right? Uh, so and then I have added one constructor here, right? t1 and t2 is taking x and y. I am basically here initializing using the initializer list, and I have added one get value function. So this will basically what it will do, it will print the x and y value here, correct? So this is a template entity, and on the class entity, and on the class entity we are applying the template, so it is a class template. I hope it is clear now. So now how can we, so this is the basically definition of the class templates. Now how can we instantiate the class entity here? So see, so likewise in function also we were passing the here this arguments, right? So like in class also we have to pass the arguments here, double and int and double, right? So because t1 and t2 are the separate, so we can pass the two right, separate data types also, so don't be confused, correct? So now we are passing double and int. So now it is necessary there must be object int. It can take only double and int, because t1 is used here, t2 is used here in the constructor. So now here basically this constructor will be created for double and int data type only, right? And one more copy of this class get created which will be for int and double instead of double and int, correct? And here I am passing the value likewise only, and the two copies of the my class will get created, right? uh, Correct. And here while accessing we can object underscore int. So the first object will be used to get value. So here this will be called for the first object, that is the separate. So let me print this one. It will print the this first one data, and the object underscore double, it will print the second data here. So class templates. So here now a dot exe. See here 3.1420, this is the first object, and 10 and 628, this is the second object. So this also proves that the separate copies will be created for class also, where first object right on the basis of the provided data types, right here. So I hope it is clear now. Now coming to the variable templates here. So likewise function, for function also on the basis of data type we have generic functions. Likewise we can create a generic variable which allows to take multiple data type values, right. So here I have added this double, right, well, and now I have here created a generic variable here, right. So this is the data type of the T is the data type, and how we are taking T is a templated type, right, type name. So T I have using to declare this myvar here, right, myvar here, and this is taking the val here, right, val is a double value, correct. Now I am basically here instantiating this myvar, or you can say using myvar. So here, as I have already explained you, while defining we have to use a template to define the data types, and while instantiating or while calling, right, we have to say here like for which data type we are calling, right. So here also we are giving boolean, double and int, right. So one, this myvar is for boolean, one copy for this one will be created, myvar for double, one copy for double will be created, and myvar for integer will be created. So three separate copies will be created by the compiler in the while the compiling, right, or you can see in the assembly file. I have already shown you how can we see that, correct. So let me print this one also. So a.exe got created. See here, my where edge float 1, double for double value getting printed, and my where as an integer will be printed here, right. So integer copy will be invoked here, double copy will be invoked here, and boolean copy will be invoked here. So I hope it is clear. Now requirements of the template, right, to avoid the duplicacy of the code, we this template came into picture. Using the template we can write a generic code which can take the arguments as an basically data type as an argument, like we take the values, right, and then we can write a generic code, simple single code here, right, instead of the multiple code here. We have added one now, or you can say in other words you can say that like the job got transferred to the compiler to add a separate copy on the basis of the data type. Okay. Then there are three types of templates, and the entity on which the template get applies, right, and the instantiation of the templated entity. So now on the basis of entity, if we apply the template on the function, then that is called function template. If we apply the entity the template on the class entity, then that is class template. And if we apply the templates on the variable entity, then that is called variable templates. Now I hope this is clear to you. Now going to the advanced feature of the template, we can see here the specialization. So now coming to the template specialization, basically what does it mean by template specialization? In simple words we can say add a special function for a special data type, right, or in other words we can say this template specialization allow the programmer to customize the behavior of a templated entity. Now templated entity could be class or function, right. Variable specialization does not supported in the C++. I have took the example of the class. So in class what we are doing here, so here this is the this code will be invoked for each and every data type, right, while instantiating the class object. But now I want that this code should not be invoked for particular data type. So for example, integer data type, for integer data type I want to write a separate copy, right. So in that case this should not be invoked. So now how can we do that? So we have to pass the empty here, right. Here a template argument list should be empty. So now for this one I am directly giving this integer to the here class printer, and I am here defining or you can say giving the integer data type directly, right. So this is the syntax of the template class template specialization, you have to remember, right. So now this class got specialized for the integer. So now if we instantiate the object of the this printer, if we instantiate for the integer, then this code will be invoked, and if other than integer, the generic code will be invoked, right? And the compiler will create the separate copy. But for integer, compiler will not create, or you can say in other words, this is a way of telling the compiler that for integer, do not create your own copy. I am providing the copy for the integer. I hope it is clear, right? But now this is the full specialization. Now if I want to specialize only for the subtypes, not the main types, right? Main types like integer, float, double, character, like this, but if and the subtypes like pointer, right? So pointer of integer. So for subtype I want to specialize, then that also we can do. And here this is the syntax of partial specialization basically, right? Partial specialization allows customization for a subset of types, right? Or you can say subtypes here. So here t pointer, right? So for generic pointer, for pointer we are basically telling the compiler, do not create a copy for the pointers I am providing, right? Now compiler will create the copy for the for example, this is for integer pointer we are calling, so it will create one copy for integer pointer, and other, if we are basically calling for the double pointer, then it will create the copy for the double pointer, right? But the copy of this code, right? Copy of this this code basically here, not the copy of the generic one, this one. I hope it is clear to you, right? So the specialization is a way, or you can say the specialization feature allows us to create or customize the behavior of the templated entity. Now entity could be class or function, right? So this is the example of the class where we are basically specializing the class template here. So I am building, this is done. So now print or run the exe here. See, generic printer 3.14 here, p1.print. So double, right? So for double, the generic will be invoked here, because for double one copy will be created and with the same information or functionality, right here. So generic printer will be invoked for double here, but for integer here, for integer printer, integer entity will be invoked here. See, integer printer will be invoked here, because we are saying compiler that do not create copy for the integer. For integer I am providing you the copy, and you can use this one, right? So that is why. And for partial, so if I am giving the pointer here, see here, well, and address of well, I am passing this one, and right for double pointer, so I am invoking this printer for double pointer, right? So in this case the partial one will be invoked here. See here, partial specialization printer invoked here, partial SPL printer, right? This one, it means this class got invoked here, correct? I hope it is clear. Now coming to the function specialization here. So likewise, the class is template specialization, there is a feature of function template specialization, or in generic way you can say entity specialization, right? Now this specialization is allowed only for class and functions, right? Not for the variable templates, correct? So here I have added a generic function here, this one, using the template. Now this function should be invoked for all except the specialized one, right? Why specialized one? Because using the specialization feature, we are basically telling the compiler not to use the generic one. Instead of that, for this specific type, right? For integer type we are specializing this templated function. So for integer type, this function should be used instead of the generic one, right? So now compiler will not create the one copy for the integer of using the generic function, right? Instead of that, it will use the provided function. And for partial specialization here, for t pointer, as I have already explained you, the partial means the specialization is done for the subtypes. So here I am building this one, and then here I am running it, that exe. See, so here for this integer, this copy of integer, whatever we are providing specialized version, right? So this version will be invoked, and for double, the generic version will be invoked, right? So this one, generic one, correct? So this is the version where we are specializing for subtype, right? We are passing only t only here, but the specialized, but we are using here t pointer. See here star, So this version will be invoked for the integer pointer, because here we are passing the address. So I hope it is clear, right? The class and function template specialization is clear, right? So the template specialization is basically this feature allows the programmer to customize the behavior of the templated entity. Now we will discuss the default argument, like the types of the arguments in the template, like type type arguments, non-type arguments, and default arguments, right? So default means like here in function also we I hope you know about the default arguments, where we, while declaring or defining, we can give the default arguments. If we are not passing, then the default arguments will be used. So that is the same feature which is applied with the templates as well here. So here in the templates, at the time of template definitions, we are giving this string to T3 and double to T2. So these are the default values which will be used for the type. If we are not providing, if we are providing, then that will be used, right? And T1 is not a default argument here, right? Default parameter. So here T1, T2, T3, I have added a class, right? And then here I have added a function also, and here this is the non-type. So now see, type, non-type, and default. So this is the example of default, right? And T1 is the type name, right? So this is the type name. T1 will take only type name. But now there is another type of parameter in template, that is non-type. So now integer n. See, this is the parameter of integer. Here type is already there, integer type, right? So this is a non-type. It means, and the condition of non-type is it must be a constant, right? So this is a type parameter, and here integer we are, like type name we are already giving here, right? So this is a non-type parameter. So now here this is a function, right? And here we are passing, basically we are expecting one non-type parameter and one type parameters for the template while instantiating this my function here, right? So see, my class here, integer, float, and string, we are passing integer, float, string, right? And here this is double and this is string, but now double will be not used because we are passing, so now float will be used, correct? And here we are instantiating it. And here in the second example, second call, we are only calling the character only, right? The other two will be default one will be used here, right? Double and character, double and string, this will be used. So now here there will be a two copy. One copy for int, float, string will be created by the compiler, and one copy for the character and double string will be created, right? Combination of these three will be created. So two copies of the my class will be created by the compiler and will be used, right? So that is what we are doing here. And now coming to the this function one, non type and type. So here integer we are passing data type because this is expecting a type parameter here, right, for my function. And the second one is it is expecting a non-type, so that is what we are passing a non-type n. N is a constant, correct? So I hope it is clear. Like in function we pass the arguments, likewise in templates also we pass the argument. Now the arguments type could be, it could be a type name, it could be a non-type also, right? And if it is a default argument, then we there is no need to pass the arguments as well, right? So let me build it. I am building this code now. Build is done. A.exe. See here 10 5.67 and hello, it is got printed from here, this one, right? And from character here the second one is default, and the sorry, these the second the remaining two will be used from the default, right? Double and string. So here a is character, that is what we are passing here, right? This one is character, and then this is passing character, and third one is double, and this is a string, that is what used here, right? And in the function also we are passing n and integer. Integer a type, right? This is a type parameter which is expecting, and a non-type parameter which is expecting here, this function entity, right? So this n here, n can directly be used inside the functions, right? So here n I am using here, and this t I am using here, t of variable type of, the t is the type of variable, right, input argument. correct? And here t I am passing 10, so here 10 numbers are getting printed. This loop is running for 10 iterations, n iterations, n is 10, correct? I hope it is clear. So now let's discuss the template argument deduction. So basically this is the feature of the templates which allows the compiler to automatically reduce the template parameters on the basis of the function or class argument types, right? For example, here see uh, uh, in function, right, my function, uh, see this one, yeah, right, in the C++ function template example, here this is the templated function, right, which is expecting one type, right, template as a template parameter, right? So now here this is the way initially, but if I do not provide this int here, then this will automatically, the compiler will, while generating the copy of this my function, the compiler will automatically reduce the data type on the basis of the whatever the argument we are passing to the function. So here I am passing integer, so one copy of integer will be created here, or you can say the t will be uh, reduced to the integer, right here. And if I am passing here double, if I am passing here double, you can say this one, this is a double, right, without explicitly passing the data type. So now one copy for double will be created on the basis of the argument we are passing to the function. So this is the automatic reduction of the data type, correct? And this is for integer. Likewise for class also, but for class this feature came into picture after C++17, right? So if your compiler supports C++17, then you can omit passing the data type here, right, while instantiating the templated class entity. I hope it is clear. So now let me build it. I will not remove this one because it will give the compile time error because my compiler does not support the C++17. So that's why I'm keeping the class entity with the data type, explicitly specifying the data type. See here 10, 20 and 20.123. So this 10 got printed from here, get value from the class here, because here we are specifying. But for function, I am passing 20 and 21.3. So for one copy for integer will be created and one copy for the double will be created, right? So I can show you. So this dump file got created here, this one. See, and here if I search my function, see, so these are the calls, one for integer, other one for double, right? See here in call itself, this got added automatically, double and int, right? But we did not add anything. So compiler will took over and it will add the here itself, and on the basis of that it will create the separate copy, right? See here, one for integer, another one for double. So I hope it is clear to you that this feature is also there with the templates. If we omit by explicitly specifying the template argument type, right, or template arguments, then compiler will automatically add them on the basis of the whatever the function arguments we are passing, or whatever the arguments we are passing while instantiating the class objects. Now coming to the template metaprogramming. So this is an advanced feature of the template. For example, we want to do some calculations, and so that calculation, if we are doing that calculation using the functions, then that will be basically calculated or the computation will happen at the runtime. But using the template metaprogramming features, this calculation can be done at the compile times using the template features like specialization here, right, and here non-type parameters of the template, and here recursive calls. So these three features, or you can say sub features of the C++ which we are using while achieving the template metaprogramming, or you can say by achieving at the computation at the compile time, right? So what we are doing here, basically I have added a generic like template here, template entity factorial. This is a struct, right? And here, and instead of the type parameter, I am taking non-type parameter of the template here, right? And correct, I have already explained you non-type parameters, and this n is using here, and n minus 1 is getting used for recursive calls of the factorial, right? Struct itself I am calling recursively. And here as you know, for recursive calls there must be a base condition, else it would be infinite calls. So for base condition, what I am doing, if n is 0, in that case this version should be called instead of the generic one, right? So for 0 known type, I am specializing the template here, right? Here specialized version of the factorial here, right? If n is 0, then use this piece of code instead of the generic one, right? Or you can say, in other words, what is happening behind the scenes, the compiler will create as copies of n equals to for example, here I am passing 5, right? So for 5 it will create one copy here, for 4 3 2 1, and for 0 just it will use this one, right? It will use this one, and then it will and all these things happening at the compile time. As you know, the template get resolved at the compile time by the compiler only, right? So by seeing this code, what we can say, the compiler is generating separate copies, and it is also calculating at the compile time. So now what we can say here, so this call, right, this call will get resolved at the compile time, but this call fact call will be resolved at the runtime. So what does it mean? It means this res will have the result at the runtime, but this call fact function, in this functions here, one temporary variable will be created, and that will be having the value of the factorial 5, right? And what we are doing here, we are basically n multiplying by n minus 1. So this is the factorial function. So here if we are passing 5, then here the value would be factorial of 5, that is 120, right? So that we can see in the assembly file also. So let me create the assembly file using -s option. So here assembly file got created .s here, and here if we go to main function, so where is main? So this is the starting of the main function definition, and from here we are calling the call fact function. See, call here, call fact, right? If you know the assembly, then it is very simple for you. So call fact. So now let's go to the call fact definition here. So this is the starting of the call fact function, right? This is your call fact function, this one, right? And here in call fact functions you can see move, right? This one 120. So this 120 is calculated at the compile time only, because this assembly file is getting created by the compile at the compilation stage, right? So at that time only it is directly calculating, it is directly having, here we can see 120 instead of the some variable like here percentage eax, right? And this is moving to some temporary or you can say this variable in the memory at this location eax, right? So by seeing this, you can say this factorial 5 is getting resolved at the compile time. The calculation is happening at the compile time only, right? I hope that is clear to you. I have shown you the result also in the assembly file. So that's all for this video. I hope you are clear with the template related queries. If still you are having some query, then please comment below the video. I will address your comments in the comment sections, and I will provide I will try to resolve your query, or else I will take a separate video for your query. Thank you for watching the complete video. See you next time. Till then, keep learning and keep exploring.